and I will call the each and every author by their paper ID. So let us start. And again, I would say thanks to you all that you have presented your given your paper that has gone to a peer reviewed uh, way before, and this ICSMC you have been given this opportunity to show your presentation, and the best paper award will be given to them. So first of all, I just want to ask paper ID 45, uh, Professor Aswini BT, to please share your presentation and start.
Okay. One second, sir. Is it visible?
Yes, yes, it's visible.
Uh, Good afternoon, everyone.
Please make it in a full mode.
Okay, okay, sir. Uh, Good afternoon, everyone. I'm Ashwini BT from Assistant Professor, Department of Civil Engineering from Atria Institute of Technology, Bangalore. So my research work is it is on CSAN. Uh, this is durability characteristics of CSAN in the cement mortar for the construction. So we are replacing the river sand with the sea sand, and we have we have determined the properties of the sea sand with the comparison with the river sand as per IS 2386 codal provisions. So normally the river sand will be having the some of the properties like bonding, specific gravity, uh, uh, specific gravity, fineness, particle size distribution, and bulking density, silt content. So normally the river sand will be replaced. Nowadays, it is replaced by the manufacturing sand. And due to this manufacturing sand process, some of the the weathering rocks are, disintegrated, and due to this the erosion of the rocks and soil it is happening. For that reason we thought to use the sea sand as a replacement for the river sand. As we know, the river sand is a natural sand which is available in the bank of the river. Due to the it is a natural process of the weathering, where the rock particles will be disintegrated and it will be stored in the bank of the river. Similarly, the manufacturing sand, it is called as M sand or robo sand, which is artificially prepared. So it is called as artificial sand, which is prepared by using crushing machines and crushing the granite
Hello,
stone.
sir. I'm here.
Hello.
Hello. Hello, sir. I'm here.
Crushing the granite. Hello.
Yeah.
Shall I continue, sir?
Yeah, you should continue.
Okay. So by crushing the granite stones in a quarry, so normally the M sand will be compared. It is already done. The research work has done, and it is already compared with the river sand. By and the properties of M sand, that is strength and durability characters, is compared with the river sand. It is satisfied with the comparison, and now it is already in use. M sand is in use. uh, as the M sand, it is not a natural process. It is done by artificial process. So the production of M sand causes the air and water pollution, and it is leading to the global warming. So in this research work, we have used the sea sand, which is naturally formed uh, by the process of weathering of rocks, and it is settled at the shore of this ocean or sea. So this normally the sea sand will consist of chloride particles, as the it will be it, uh, for that reason it will it causes the erosion, corrosion in the steel particle, steel which we are using in the construction. So in this present study, we have done the durability characteristics of cement mortar by replacing with the CSAT, and we have replaced 10 10%, 20%, 30%, and 40%, and we have
Ma'am, your
completely.
slides are not moving, ma'am.
Okay, yeah, sorry. So in this study, we have replaced this 10%, 20%, 30%, and 40%, and the complete river sand is replaced by 100%. And we have given.
Just sorry to intervene, Ashwini.
Yes, sir.
Your slides are not
No, no.
moving, and your sound is also very low.
Okay, yeah.
Maybe there be some technical issues.
Okay. Now it is. Is it okay, sir?
No, no. Actually, you close it and then again share your screen,
Okay, yeah.
and please share the entire screen.
Okay, sir.
You are not. Your sound is not there.
Yes, yes. Sorry. Uh, so these are the material properties of the cement. So as we have done cement mortar, so we have tested the cement as per the standard IS 1489. We have done normal consistency, initial setting time, final setting time, fineness, and specific gravity. So these are the obtained values of this experiment, properties of the cement. So the range, the normal consistency range will be 26 to 34%, and we have got 32%. Initial setting time 30%, we have got 30 minutes, and we have got 30 minutes. Final setting 600, so it is 600. Finest 10%, less than 10%, we have got 55%. Specific gravity 2.9 to 3.15, so we have got 3. Similarly, we have done the basic properties of fine aggregate, that is both river sand and sea sand. So the specific, as per the codal provision IS 2386, so the specific gravity it ranges from 2.65 to 2.67. For river sand, we got 2.4, and for sea sand, we have got 2.82. Silt content, it is less than 8%. For river sand, we got 4%, but for sea sand, it is 0%. Fineness 2.75. And for river sand, it is 1.7% by weight of aggregate. And for sea sand, it is 0.5%. Total water absorption less than 3%. It is 1.3% by weight of aggregate. And sea sand is 1.3%. Bulking of sand less than 5%. It is 5.2. And for sea sand, it is 14.2. Grain size analysis, it is less than 4.75. Zone 2, 90 to 100 mm for river sand and 50 to 200 mm for sea sand. So the methodology we have done for cement mortar 1:6, and we have prepared the sample according to IS 2250 1981. The workability of mortar is checked by using flow table test. It is referred from IS 14031, and the compressive strength of mortar cubes it is done. Then the durability of mortar cubes, it is both, one is carbonation test according to IS 3466 and chloride test with respect to one, IS 14959 we have conducted. So the flow table test, it is normally it is used to measure to find the workability of cement mortar, where the cement mortar is placed in the mold, and the rotation, it is like 25 blows we will apply. The spread of the mortar we have measuring, that is D average is the average base diameter, and D naught is the our original base diameter. So D average we will find out by taking the measurement on the disc, and we will calculate the flow of the mortar. So normally the flow of mortar should be 25 mm. So this is the compressive strength. For mortar cubes, we are using 70 mm into 70 mm cubes, and it is cured for 7 days and 28 days. The compressive strength it is find out. For this experiment we have referred from the paper 5, that is I have already published in GRD General. So from that journal we have taken the reference, and we have calculated only the durability. We have done the durability test. So carbonation test. So here, normally the cement consists of calcium aluminate and calcium silicate. So when it is reacted with the carbon dioxide, it will produce the calcium carbonate, which causes the deterioration. That is nothing but the crack in the mortar or concrete, which will reduce the strength of the cement mortar or concrete. So we have used a thermocol chamber where we have burned the specimens for 24 hours. After this, we have applied the phenolphthalein. Yes,
Ashwini ma'am.
yes, sir.
Ashwini ma'am.
Yes, sir.
Yeah, actually your slides are not moving. So I recommend that you means, close
Sir,
it and try to do it again, because the slides are not at all moving.
okay.
Because we are placed at yeah. Now yeah, and please try to make it an presentation mode.
Yes, sir. Yes, sir.
Then it will be clear to all.
Is it okay, sir?
Yeah. Okay, it's fine.
Yeah. Once after the burning process, the sample is taken out from the chamber, and it is the sample is applied by spraying the phenolphthalein indicator. If the carbon dioxide is present in the sample, the color will be it will be colorless. Otherwise, the sample will change changes the color to pink. So this will gives the deterioration factor. So similarly, we have conducted the chloride test. We have taken the sample of mortar, cement mortar, and we have mixed with the nitrate solution, nitrate acid, and distilled water. And this sample is titrated with the silver nitrate solution, and the color changes to the pink. Wherever the color changes, we will take the sample and we will calculate the chloride content which is present in the cement mortar. So this is the result and discussion. These are the flow table readings. The river sand, it is completely, it is made up of 0%, where we have not used any sea sand. And from 10%, we have replaced the sea sand with 10%, 20%, 30%, 40%, and completely 100%. The flow mortar reading, that is the measurement of the workability, it is started for the river sand, it is 20 mm. For 10% replacement, it is 55, 20% replacement, it is 65, 30% it is represent 67.5, and 40%, 69.2, 100% is 73. Next, carbonation test. Here in the carbonation test, we have taken the weight of the sample, that is cement mortar cubes, before and after the test, before burning. That is given in the, it is taken in the grams. And after the burning process and applying the phenolphthalein, we have again taken the weight. There is decrease, there is a slight, in all the samples, there is a slight decrease or increase in the weight of the cement mortar cubes. But in 20%, there is a increase in the weight due to the carbon reaction. And the next chloride test, here the sample is, after testing, we have taken the chloride amount, we have calculated the chloride amount in terms of gram per meter. So that is the, for 0% it is 1.06, 10% 2.94, 20% it is 3.92, 30% 4.9, 40% 5.8, and 100% it is 66.95. So these are the conclusions. The comparison of experimental work performed with the partial replacement of sea sand with the river sand. The cement mortar gives the following reference, where we have used the Malpe sand, which is near Mangalore, and the fineness of the sand is less than 75 micron, and it is satisfied the IS codal provisions. The compressive strength for the cement mortar cube for the 20%, it is normally exceeds compared to the river sand. It is similar to the river sand. The fresh mortar which is used with an increase in the cement sand gives the good flowability compared to the river sand. The chloride content results will increase the sea sand percentage and the chloride content, which leads to higher corrosion, and it gives the strength and durability will decreases. In the carbonation test, there is an increase in 2% of weight for the 20 and 30% replacement. This so by this, as the result shows, we can replace only for 20% from this research work. The sea sand can be replaced with the river sand up to 20%. Thank you.
Thank you, Ashwini. Sorry for the intervene. You have your slides were still not visible. I don't know what's happening. There might be some technical issues.
Okay,
But okay, anyone having or wish to ask any question, they may write in the chat box, and then we will raise those questions. And this information is for all the authors. That if someone walk in the question answer round, if someone wants to ask some questions, they may write in the chat box, and we will discuss it in the question as an open forum. Abhilash sir, if you wish, you can ask.
Yes, I have some particular questions, Ashwini ma'am.
Yes, sir.
From which area you have taken the sea sand?
This is from the Mangalore region, sir, Malpe Beach.
Bangalore region.
Yes,
So what are the differences in the physical property you observed?
Normally, what we have done,
Significantly, only significant.
the specific gravity is, the silt content is more compared to the river sand, sea sand, and the binding property is very less compared to the river sand.
How did you evaluate the binding property?
Yes, sir. Can you repeat?
How did you evaluate the binding property of the sand with cement? Have you worked on the interfacial transition zone or some imaging which shows that there is a less generation of CSH at the interfacial transition zone?
No, we have not done any experiment on this, but as per the previous studies by some of the research paper, we got to know this, the binding property, if the addition of sea sand in the cement mortar, which will reduces the binding property, due to this the strength will be decreasing.
Okay.
Yes, sir.
So actually, didn't you find any difference in the chemical composition?
Chemical composition, we have not done any chemical composition test, sir.
You should work on the chemical composition part also, because when you're taking from the sea sand, it is expected to have some traces of fluorides.
Yes, sir.
I think magnesium oxide and carbonates also.
Yes, sir.
So that may harm the concrete. And please
Actually,
replicate these studies in the concrete also, because you have done only for the mortar specimens. That
yes,
is
yes, sir.
fine for the conference work.
Okay,
But
sir.
what I suggest is you can expand your work with concrete also, and check on the workability aspects also.
Yes, sir. Yes, sir. Sure.
Okay, so this is
Yes.
my kind suggestion.
Okay, sir.
Okay, thank
Actually,
you.
I'm doing my PhD in this field only. So we have
Which
done
university you are doing PhD?
VTU, sir. Vishweshwara Technological University.
Acha, VTU. Okay,
Yes.
okay. Okay.
Yes.
Good.
Yes.
Okay, Ashwini, thank you very much. Thank you, Abhilash sir, for your kind suggestions. Next paper ID is 238. I would like to invite presenting author Deepak MS to please kindly upload his presentation.
Very good afternoon, sir. I'm the co-author of MS Deepak, so he's not available.
Okay.
So I'll be presenting both the papers.
Okay. You please continue, ma'am.
Yeah, fine. Is it visible, sir, my slide?
Yes, it's visible.
A very good afternoon to one and all. I'm very happy to be part of this ICSMC 2021 conference organized by JUIT. And I'm Dr. Abhilash Shukla Anandi. I'm working as Associate Professor in Anna University, Chennai. So the presentation of my work is the topic of my presentation. Today's presentation is improvements in tensile strength properties of steel after forming. So as you all know that the steel has a very unique characteristic in its form. That is, before forming it has certain properties, and after forming it has certain properties. The main properties, the variations in which we can see is in the yield strength, before the yield strength and after the yield strength. That is the initial stress difference, and after the yield strength, the pattern of the stress pattern differs. So to generate or to generalize the properties, these studies has been carried out. So the cold form steels is used in most of the construction industry, since because of its lightweight and high strength, and it has a very desired shape and mass in productions can be obtained. And these are some of the advantages which I have highlighted here. And they can be these cold form steel members.
Ma'am, your slides are not moving, ma'am. Please make
Now,
it in full screen mode.
it's already in full screen mode only, sir. Now
Actually, I think then you have to share it. You have shared the presented as an entire screen or as a window.
let me see, sir. I think I've shared as a window. Now is it okay, sir? Is my slide moving, sir?
Can you just, now it's moving. So please make it on to the full screen mode.
Is it moving now, sir?
No.
Yeah, if I make
And
it
it
full
is
screen, it is not moving.
okay. It's okay. No problem. Make it minimize only and we'll start. Yeah, we can see and it's moving, so no issues.
Yeah, this is fine, no, sir?
Yeah, fine.
Yeah, it's fine.
Yeah. So the cold form steel members are slender thin wall profiles, and they can be manufactured from thickness 0.8 mm to maximum of 3 mm thickness. And these are some of the deformed shapes which is possible in the flexural members. For the short span slender members, it fails in local buckling, and for the medium spans it fails in the distortional buckling, and for the large spans it fails mostly in terms of lateral buckling. And open sections, open cold form steel sections, they fail in the torsional buckling or a combination of lateral torsional buckling, lateral plus torsional buckling. So the main advantages of the built-up sections are they can be fabricated into any different formations, either as a box shapes or an open shapes, put together as a two different components or a multiple number of components. People have tried with many different cross sections, and when you study the exact configurations of any segment, we need to find the basic properties of the steel. So these are some of the buckling modes which I have highlighted here. So the local buckling mode, distortional, lateral distortional, and lateral torsional buckling mode. You have L, D, F, which are the local distortional, flexural, torsional, and FT, which is the flexural torsional buckling modes possible in the single sections or as a combination of these six which I have highlighted here. When you have multiple number of components, maybe one or two combinations of sections put together. So these are some of the failure buckling modes. So before we study this, we need to find the elemental properties, which is the basic stress from the basic stress strain curve. So the cold form steels is available in the sheet form. So before we fabricate, we need to cut the segments, which is called as the before forming. And after the geometrical shapes is formed also, the segments can be cut and the properties can be obtained, which is called as after forming. So the present study involves the stress strain responses of multiple grades of steel, which is expected to give a clear understanding in the design optimization procedures. The yield and the ultimate strength of plates increased due to the press breaking mechanisms. So the press breaking mechanism is the one in which the shapes of the geometrical components is arrived. So because of the press breaking mechanisms, the strength and the it can be either yield strength, the ultimate strength, and also depends on that your stress strain graph, your Young's modulus normally it may increase or it keeps on with that basic value of 2 into 10 power 5 megapascals. So the ductility is reduced and the modulus of elasticity value is enhanced due to the cold press break forming of all the grades of steel. Is my slide moving, sir?
Yes, ma'am.
Yeah.
Please continue.
So the developments of the cold form specimens, you can find that how this press breaking is formed from the sheets. The sheets are cut into the segments, and depends on your geometrical cross sections. Each and every individuals are cut and then they are assembled. So they can be assembled using this bolts, which is called as the M10 grade bolts, or if the thickness is very less, we can use even the self drilling screws. So this is one of the example from which the segments, the stress strain graphs for these for this web sections and from the flange sections are cut from the before forming and after forming. And this presentation involves the stress strain pattern after forming. So this is in hybrid sections in which you have four channel sections in which the top and the bottom, the flange channel section has got the stiffeners, whereas the web portion doesn't have the stiffeners in it. So the main objective is to study the pattern of behavior based on the European standards, which is the EN ISO 6892, and the flat faces of the closed box sections in which the new models can be proposed. The tensile capacity is obtained for the sheet cut coupons, and the sections is cut and they are compared and analyzed. So three different ways in which they are cut. One is the longitudinal, transverse, and in the diagonal directions. So here, these are some of the review of literatures in which you can find the various stress strain stress strain patterns of various metals. Here, this Brennick et al. He has studied the chromium, nickel, manganese at high temperatures. So the stress strain graphs can be studied not only for steel, either for hot rolled steel or for cold rolled steels. It can be studied for any metals, irrespective of the nature of the temperature. It can be an ambient temperature or it can be an elevated temperatures. Many of the literatures in the recent parts gives the detailed behavior of stress strain patterns of aluminum and stainless steel studies relevant to the high temperatures. So these are some of the literatures which any readers, if you are interested, you can see to it and you can learn a lot apart from what I have highlighted here in my presentation. The presentation of mine is only the extension of these literatures which I have given. Only few literatures I have highlighted here, which is the basic for my study. So the material properties here have taken three different study pattern. One is the cold roll low tensile strength steel, and you have the hot roll medium tensile strength steel and hot roll high tensile strength steel. So which is demarcated, or which is abbreviated as CRLT, HRMT, and HRHT. So the procedures in which it is formed is highlighted here. So the automatic shape and gauge regulations are used in order to get the closest tolerance of the thickness. And here the electronic cleaning line with 100% hydrogen atmosphere batching is done. So here you have to be very careful while cutting the samples based on the recommendations given by the European standards, without any rust formations on all the surfaces. So dehumidification units for improving the flatness of the strip and oiling must be done. The chemical composition ensures bendability and weldability of the products. So here you can also make note that the oxide films are removed through acid batch processes. So these are the three steel taken, which is the CRLT, HRMT, and HRHT. As per the European standards, Japanese standards, American and international German standards, the normal class strength it falls within the range. So these three grades of steel which has been taken for the testing falls within the limitations as per the European code. So the manufacturer's prescriptions, all these specimens were procured from the Tata Steel. So the Tata Steel people, they have given their manufacturing standards, and even it was tested in the laboratory. The standards prescribed by the manufacturer and the one which was tested in the laboratory falls in line with that. So here, as I have highlighted the longitudinal transverse and diagonal directions, it has been cut from the stiffened flange elements, from the breadth of the web and from the depth of the web. So the coupon preparations to examine or to study the stress strain behavior is shown here. So this is the pattern in which the coupon has to be extracted before forming. Before forming means before the elemental composition is cut as per the required shape from the coil itself, it is cut. So this is the dimensions as per the European standards, and this is the coupon dimensions as per the European standards after forming. So here you can find the two channel sections which is acting as the web, and the two channel sections with the intermediate stiffness which is acting as the top flange and the bottom flange in this geometrical cross sections. And you can see here the bolts, M10 bolts are connected across the length of this flexural member, and these highlighted parts shows where the cut section. See the rectangular. One may think why this particular cut form is rectangular, but the dimension which I have shown here after forming and before forming as per the standards, European standards, is different. So first of all, before forming or after forming from the sheets, this rectangular pattern of 380 cross 50 and 300 cross 30 is cut. And from this, they are numbered. So you have to be very careful in numbering. Say one is cut from the left side of the web of the member, and two is from the top flange of the member. Likewise, you can number. And from these rectangular formations, in the machineries, as per I have highlighted how to cut, they are cut into the required form as per
Uh,
the geometrical shapes.
sorry to intervene, ma'am. Actually, we have only allotted 10 minutes for the
Yes,
presentation.
sir. Yes, sir.
Kindly sum it up.
Yes, sir. Yes, sir. So this is the tensile testing machines, and here the displacement control method is used. And here the stress strain graphs for the low tensile, medium tensile, and high tensile steel is presented here. So here you can see for the low tensile the large elongation and necking, and for the medium tensile it exhibits normal ductility, and for the high tensile it has low elongation, quick fracture, and it shows low ductility pattern. So here, these are some of the outline of the tensile testing outputs. And you can see here, most of the geometrical cross sections before forming and after forming for the 3 mm thickness in transverse and in the longitudinal sections shows much variations in the graphical representations. So you can see the increase in the ultimate stress after forming because of the ductility nature. So when it is formed into the defined shapes, it exhibits the elongation patterns. Therefore, the ultimate stress and also the yield stress, it is slightly increased. So this is the entire graph for the full stress strain graph, and this is the initial part before the this is the before your yield stress. So you can see up to 0.1 of strain. This is shown very clearly that you can see before forming and the variations in the longitudinal pattern and in the transverse pattern. So this shows that the module in which it fails. So there is a 22% and 8%, 13% increase in the percentage increase in the coupons, which is cut in the longitudinal directions, whereas in the transverse directions for the low tensile, medium tensile, and high tensile, it shows a marginal increase of 17, 9 and 17% for LT, MT, and HT respectively. So from these observations, for the coupons which is cut in the transverse directions and in the longitudinal directions, shows the pattern in which the variations is much higher. So all the materials used in the study satisfies the required criteria. The material properties which is converted into the engineering, the engineering stress strain is converted into the true stress strain curve as per the formulas, and they are put into the modeling procedures which can be used in the parametric study. So this is the fracture mechanisms, the various shapes of the fractures which you can observe for in the longitudinal direction and in the transverse directions for the coupons which is cut on the web portions, flange portions respectively. So to conclude with, the Tata Steels, which is procured for the testing, the products manufactured through hot roll process displayed sharp yield point stress strain response, and the yield strength and the ultimate strength of the plates are increased after the press breaking. And the higher the cold forming segments, the higher is the increase in the yield strength. The yield strength and ultimate strength are increased after the press breaking. The corner regions where the cold forming is more exhibited with the yield stress, elasticity modulus compared to the flanges is higher on comparison. This particular point is in lieu with any of the previous researchers and the forthcoming research which is going up. On the other hand, the material ductility of the cold formed steel is reduced considerably. So you can see the variations is 10%, 7%, and 9% increase in the longitudinal directions, and the transverse directions it is 7, 5, and 4 for the low tensile, medium tensile, and high tensile steels respectively. And these are some of the references. I would like to suggest that for the people who are interested to do their studies on any of the metallic properties, these observations must be done before they venture into their study. Either it can be a stainless steel study or aluminium studies or whatever, because apart from the applications of this in the finite element method, why the basic need for doing this stress strain graphical representations or deeper study into this is this can be taken up for the finite element modeling for the geometrical imperfections. And as per the previous literature studies, both the residual stresses and the corner strength enhancement doesn't play much influence in the predicting the failure mechanisms using the finite element method. Thank you. Thank you for all the people who has listened. Any queries, please?
Thank you, ma'am, for this wonderful presentation. Actually, you have taken a bit amount of time, but still, work is really commendable. So, anyone who wishes to ask anything, they may write in the chat box. We will discuss. Otherwise, we can move to our next. Ma'am,
Yes, sir.
you have your one more
Yes,
paper, I
yes,
think.
yes, yes, sir. Yes, sir.
So, will you continue it right now?
I'll continue, sir.
Okay, okay. Please then continue, ma'am.
I'll continue.
Okay.
Is it okay, sir?
Yes, yeah, ma'am. You please continue.
My slides are moving, sir.
Yes, yes, yes. Definitely.
Thank you for being very patient and listening to my presentation, my second presentation of mine, today's presentation. And happy to present another paper of my interest in the finite element method using Backer software, which none of the people have tried earlier. And since it's a broader study, I have cut short only with the studies related to the finite element analysis. So the title of my presentation is Numerical Investigation on Built-up Cold Form Steel Double-Decker I-Beams. And these are some of the outline of my presentation here. So the introduction of cold form steel I've already highlighted here. The basic advantage is it's lightweight and it's easy in fabrications. It can be the main advantage of the built-up open sections and the closed sections is that it can easily closed sections can easily tolerate the torsional buckling mode, and whereas the open built-up sections can carry more loads, and it differs. It depends on whether it's a flexion member or the compression member. The nature of the behavior differs. So the main failure mechanisms in the fluxural members is the torsional buckling or lateral torsional buckling. And these are some of the various buckling modes. The possible failures in the channel sections, which is the local distortional, lateral distortional, and lateral torsional buckling modes, or a combination of either of these. So the need for the present study is very few studies has been done previously on various geometrical cross sections in the fluxural member. People haven't tried with multiple number of geometrical cross sections in a combo, like one or two or more sections put together. So very few literatures are available, and in these based on the previous literatures and having a thought-provoking idea of involving three or more geometrical cross sections, this double-decker I-beam sections was evolved. And these are some of the sections which people have tried earlier in the past 5 years in various genres. So you can see it shows both the closed form sections and the open sections also. And in all of these sections, only 2 or 3 geometrical cross sections are available, except the works which is done by me earlier in the based on these literatures. the geometrical cross sections of DDI based sections was evolved. So this looks unique, and that's why I have named as double decker section. Even though it's an I section, consists of 4 different elements. As you can see, there are 4 different channel sections which are connected flange to flange and web to web, which is called as FF and WW, web to web and flange to flange. And this is constructed using the 4 different channel sections. And the applications can be applied to medium long span girders, portions of where the depth of the beam is very restricted. If the possibility of restrictions in the depth is there, this can be used. So this is the way in which it is fabricated. So here this diagrammatic representation shows that the 2 channel sections are connected back to back. Normally we use self-drilling screws, and even if the case the thickness is very large, more than 2 mm or 3 mm, so the self-drilling screws may not play a very significant role. So in that case, the M10 bowls, these are graded bowls with the washers, can be used to connectivity. So the spacing of the bowls or spacing of the screws also plays a major role, and that is the main objective of my presentation today. So the advantage of the I section is it can increase the bending resistance economically without having an increase in the steel percentage uniformly. Most of the steel sections are either slender or non-compact sections as per the RIS codes. So here the objective is to study the double-decker I-beams, which is subjected mainly to the local and distortional buckling modes. We have taken in the study, the thickness is varied from 1 mm to 3 mm, and the screw spacings are varied. So the number of screws, say for example 3 screws, 5 screws, and 10 screws are taken. These are some of the literatures, review of literatures in the past. The innovative idea of why this double-decker I section beams was chosen based on the previous literature study. So when you go into an in-depth literature study, you will arrive at a new geometrical cross sections which has more advantage compared to the previous works which is available in the literature. The main focus of how this I-beam, that is the double-decker I-beam, was obtained was it was influenced by the work done by Roy et al. In 2021, where they have tried with 2 channels which is back to back. So here, apart from these 2 channels, I have also taken another 2 channels below the top 2 channels, so that it becomes a 4-channeled section. So the work done by Roy et al. Was an influential character for me to choose this geometrical shapes. And these are some of the material properties. And since this work involves only the numerical studies, because we couldn't do any validations practically, but I have validated the work done by the previous literatures, in which the geometrical parameters, yield strength, Poisson's ratio, and the Young's modulus has been taken from the literatures. So here, these are various screw spacings. As I've told you, 3 number of screws, 5 number of screws, and then 10 number of screws. So here it is 3 screws, here it is 5 screws, and this is 10 screws. So that the spacing between the screws becomes 500, 333, and 181 respectively. So here, the study involves numerical observations of this double-decker I-beam sections, which abacus was used. In the modeling, we have used the S4R5 plates, and the stiffeners are modeled with C3D 4R, which is used worldwide. And for the meshing patterns, we have tried only with 10 cross 10, because it runs through hours. So 5 cross 5. So the mesh sensitivity analysis can be done for short spans, but for longer spans, normally we do take only 10 cross 10. So these are some of the observations from the numerical studies. In the analysis pattern, the bifurcation analysis, geometrical imperfections was taken as L by 1000, and for the local, it was taken as depth by 150. As I've highlighted in my previous presentation, from the stress strain pattern, we could incorporate the geometrical imperfections at this stage in the finite element method. That's why it becomes important to study the stress strain behavior of any elements. So it can be verified, and then it can be validated. So here in this finite element modeling, you can see for length 3000, the meshing pattern of for the 3 mm thickness for this double decker I-beam sections, and here the boundary conditions in which the multiple MPC constraint was obtained was used on the either ends, both in the left and the right side ends of the beam sections. So here, this is the buckling analysis for the 3000 length. The local buckling is shown here, and this is the distortional buckling for the same geometrical cross sections. So this is the pattern in which the loading, the four-point loading was done. One end was kept as hinge, and the other end as rollers, and the top end was loaded, the transverse load at 2 points. And for the validation study, as I've told you, the Roy et al. 2 channels back-to-back section was taken as the reference, and I have studied I have validated the pattern in which the failure happens. They have a experiment was conducted by those researchers, and using those test results, I have validated in the finite element abacus modeling, and the comparison shows almost it is nearer to 1. So the pattern in which the modeling could be done for this double decker I-beam and the loading pattern, etc., was taken up from the validated study which was done. So here you can see the lateral torsional buckling for length 2000 with a spacing of 950. It is an experimental study done by Roy et al. And here it is a numerical study. Similarly, for the screw spacing of 475, the experimental study was validated by me as per the same pattern can be followed. So in the parametric study, the thickness was varied from 1 mm to 3 mm thickness, and the screw spacings was varied from 3, 5, and 10. So based on that, based on the length, I have taken from the shorter stub, very stub spans to the slender sections 2000. It can also be extended beyond 2000 for the further studies if people who are interested in that. So here I've taken the width, the web depth as 75 as a common parameter. So this is the uniqueness which you can observe, that the 5 screws and 10 screws, the variations which you can see, the moment carrying capacity. So here this is the moment carrying capacity. The variations is not very much observed at, beyond certain limit for the 5 screws and 10 screws. So it can be observed that 10 number of screws is not needed for slender columns for a 1 mm thickness, and this is for 1.2 mm thickness, and this is for the 1.4 mm thickness. So here for all the thickness which is lesser than 1.4, for the slender span sections, the 10 number of screws need not be taken into considerations, whereas the 5 number of screws itself is sufficient to carry the sufficient amount of flexural capacities. So this is the 2 mm thickness, 2.5 mm thickness, and 3 mm thickness. So I have consolidated all the various thickness into one particular graph, in which you can observe that the way in which it behaves. So here it is the 3 screw patterns, 5 and 10 screws. So here for all the 3 graphical representation, 500, 1000, 1500, 2000. So you can see beyond 1500 to 2000 mm length, either for all the 3 graphs, that is the slender columns, the change or the variations is not that very much noticeable. So the slender column doesn't for all the slender columns, irrespective of the nature of the number of screws, the behavior pattern is the same. So that can be concluded from these present observations, provided this can also be extended using any codal provisions, international codal provisions. It can be also verified. And this is the pattern in which the failure happens. You can see here for 300 local buckling can be observed, and for 1000 you can see a small dent in the top flange apart from the lateral buckling. So here it is pure torsional buckling. For 1500 and 2000 it's pure torsional, and it is lateral torsional buckling for 2000 and this is for 1 thickness for 10 number of screws. Yes, 10 means 10 number of screws for 1 thick, similar to the previous observations. Local, lateral, and here also the lateral and lateral torsional buckling. You can see it's twisted, so lateral torsional buckling is observed. So from the parametric study, it was observed that the increase in capacity was 6% for from 10 number of screws to 3 number of screws, and it was 16% for 3 thickness specimens. And irrespective of the span of the spacing of the longitudinal fasteners means it is screws. Okay, so it can also be termed as a bolts. The failure of all the double-decker I-beam sections was initiated by the
sorry for
local
the
buckling.
intervene. Please conclude, ma'am.
Yeah. So the to conclude, the main observations which you can see here is the final element model is represented the way in which the paper the output of my presentation can be extended by the future researchers and for the practicing engineers in an extended form by varying the geometrical cross sections. By varying the geometrical cross sections and the properties, new observations can be arrived. These are some of the references of mine. Thank you. Any queries?
Thank you, ma'am, for this presentation. You have two papers on this conference, and huge extensive work has been carried out, including the finite element modeling. So just one question from my side.
Yes, sir.
Is that have you while doing the finite element modeling, have you worked on the lateral torsional buckling?
In the finite element modeling for the slender columns, then the thickness is beyond 2 naturally, the geometrical cross sections, irrespective of whether it is 2 channels or 4 channels, it fails in the lateral torsional buckling bolts, which has been proved by my validation study, which I've taken from the previous literature.
So what can be done to prevent this lateral torsional buckling? If some research future scope can be predicted from that.
Yes, sir. So this lateral torsional buckling is a very critical parameter which has to be looked into. Why this lateral buckling is okay, but lateral torsional buckling is very dangerous. So we need to provide some stiffeners in between the length. So if you provide intermediate stiffeners, so automatically you can resist or you can arrest the torsional buckling failure if it is a long span. People have tried even for 60 meters length. So for 60 meters length, definitely you have to provide intermediate support systems, which is called as the intermediate stiffness system.
Okay. Thank you, ma'am, very much. So let us call our next presenter, paper ID 342, Dheeraj Kumar Singh. Dheeraj Kumar Singh is present. Dheeraj. Okay. So let us move to paper ID 29, Dr. R. Divahar.
Sir, good afternoon, sir. Shall I share my PPT, sir?
Yeah, please.
My PPT visible? Is my PPT visible, sir?
Yes, it's visible.
Thank you for giving this opportunity, sir. I am Dr. R. Divahar from AIT campus. Today I am going to present my paper entitled Mechanical Properties of Alkafine with a Low Calcium Silicate Based High Strength Concrete. The necessity of insulating material required is concrete is more widely used to man-made construction material in civil engineering world. Where demand of this concrete for construction material increased, the world production of cement has gradually increased since 1990. The global warming is caused by emission of greenhouse gases such as CO2 to the atmosphere by human activities. Among these greenhouse gases, CO2 contribute about 65% of global warming. The cement industry is responsible about 6% of all CO2 emission because of production of 1 ton of Portland cement emits approximately 0.1 ton of CO2 in the atmosphere. Although the use of Portland cement is still unavoidable until the anticipated further, many efforts are being made in order to reduce the use of Portland cement in concrete. Nowadays, we developed so many material. There as a researcher, we have started doing several research investigation with the replacement of cement material, supplementary cement material. The use of the supplementary cementitious material as a production of concrete can result in major saving of cost and energy. It also helps to improve the strength and durability properties of concrete. These effects include the utilization of supplementary cementitious material such as fly ash, silica frame, GGPS, and alkafine, metagonine. Find alternate cementitious materials, and the Portland cement has been used in recent years as a cement replacement material for the development of high strength concrete with improved high workability, strength, durability with reduced firmness. In this investigation are carried out to study the effect of alkafine, the partial replacement of cement supplementary with various percentage of alkafine. What is alkafine? Alkafine is the new generator in ultrafine with low calcium silicate. Alkafine, there are two types of alkafines are made. Alkafine mainly used, alkafine 1203 and alkafine 1101. These are the two alkafines are used. Alkafine 1203 with a low calcium silicate, alkafine 1101 as high calcium silicate. In the low calcium silicate, in alkafine 1200 series can be classified into three types. Alkafine 1201 it represents fine particle, 1202 with microfine, and 1203 is the ultrafine. Here the particle size is represented very low. It has unique chemistry and alkafine particle size. Alkafine is 123 provide reduced water demand for giving more workability in the concrete performance. Alkafine 1203 can also used as a high range water reducer to improve the compressive strength as well as super workability in order to flow. I have collected more than 40 papers related to alkafine, none of them done by using this alkafine replacement with high strength and high performance concrete. Only two was explained here. Due to time constraint, I am forward to this slide. The objectives of this the paper is in order to optimize the dosage of alkafine that can be used to replacement of cement in concrete, in order to determine the mechanical properties of concrete in terms of compressive strength, skid tensile strength, and flexural strength in addition of alkafine. And we are comparing the result with controlled specimen without alkafine, and we are summarizing the finding optimum from the both analysis and discussion of this. Methodology, we are using high strength concrete with M50 grade, the replacement of alkafine with 0%, 5%, 10%, 15 and 20% replacement of cement. These are the concrete mix selections are given below. And we done a curing for 7, we done a test the day of 7, 14 and 21 days of mass. This is the particle size distribution. Material test, we done a various tests for material. For example, if it is a cement, we done a soundness test, initial setting time, final setting time, specific gravity and consistency. I'm not projected in the slide due to time constraint. For fine aggregate, we done fineness modular, specific gravity and density. Similarly, for coarse aggregate, I did fineness modular, specific gravity and impact value of the coarse aggregate. And this is the particle size distribution of materials were used in this investigation, and physical and chemical composition of alkafine of 1203. In experimental investigation, I already told I'm going to use 50 grade. This is the total cement of consider of the CMC. And the specimen details with various percentage of alkafine. The total cement consumable is 435. I am replacing the cement by 5%, 10%, 15 as well as 20. And the casting and curing of mold is done. This is a failure mode of specimen. Totally 120 concrete specimens are done investigation with and without alkaphenes were cast. Compressive strength, fit tensile strength, and structural strength. Result and discussion. For the compressive strength of specimen, we each sample we done 3 investigation. In this percentage of variation of strength controlled at 28 days, 0, 5, 10, 15, 20. And the 5% replacement alkaphane was increased by 1%. 10% of alkaphane was increased by 2.3%. 15% of alkaphanes were increased by 18 to 20, 18.8%. It is an alkaphane 20 was reduced by 4%. This is the value of standard deviation. In this, but 20% replacement alkaphane gave 3.9 lesser compressive strength. Shows that compression strength was decreased by 2.2 megapascal. Similarly, in the variation of tables. Split tensile strength also, it is increasing up to 15%. The replacement of 5% is increased by 1.6%, and the replacement of 10% was increased by 2.2%. Replacement of 15% increased by 26.7%. After 20, it is remain decreasing started due to fine particles available there. And structural strength also, up to 20% or 15% was optimum. After that, it was reducing. After the 15% was reducing. See that the replacement of 5% is increasing by 11%, and 10% increased by 15%, and 15% increased by 20%. After 15%, the properties was reducing in this scheme. But standard deviations are similar to all the values. The conclusion, by the experimental part in the binary binary system, the alkaphane concrete based upon a fractural, compressive, and split tensile state, it was found that optimum percentage of cement of alkaphane replaced up to 15% is optimum. The improvement in the early stage of fractural, compressive, split tensile strength of binary binary system concrete was due to accelerated hydration reaction on the addition of alkaphane, similar in coding on 28 days. The decrease of strength is addition of behane of 22% was decreased due to quality of hydration higher than the laboratory, the blind concrete hydration process resulting in out of rate of decrease in a 4 bending strength. Alkaphane has a higher specific surface area with early strength gaining characteristic material incorporating increased workability strength and increased chemical effect resistance by reduction of porosity through the generation of CHS. As a result, found increasing the utilization of alkaphane can be preventing huge construction with environmental and ecological that's improved by conventional cement production. Finally, it is used for considerable reduction in cement in order to reduce the greenhouse emissions. These are the few references I have included. Thank you. Any queries? Am I audible?
Thank you, Dr. R. Diwar, for your presentation. So anyone who wishes to ask, we can ask author for their queries. Anyone? One query from my side. How can you have you done the workability aspect while using the alkaphane? Or have you used some plasticizers along with alkaphane?
No, sir. During workability also, I done a workability investigation also, sir.
Okay.
Workability was increasing by using the alkaphane, sir.
So what can be the reason for it? Because you are using you are actually replacing cement with that partial replacement of cement with this alkaphane. So what will be the reason for that?
Sir, reason is increasing the workability strength was increased due to chemical attack resistance by reduction of porosity through the generation of CHS gel, sir.
Okay, okay. So usually, what happens with other pozzolanic material is that it hampers the workability aspect of
Yes,
concrete.
sir. Yes, sir.
So unlike other pozzolanic material, this alkofine is actually increasing the
Increase.
workability.
Yes, sir. Yes, sir.
Okay, okay, okay. Have you also have you done the chemical
No, sir. My further
fluoridation?
process is going to do chemical analysis also, sir. This is
Okay,
primary
okay,
investigation. Further, compulsory I will do it, sir. Thank you for your suggestion, sir.
okay,
Surely I
okay,
will.
okay. Okay. Thank you very much.
Thank you so much, sir. Thank you.
Paper ID 294.
Sir,
Yeah, yeah. Please upload your presentation.
yes. Sir, is it visible?
No, it's not visible now. Please share the entire screen option. Please share the entire screen
Sir, I
option.
have shared the entire screen.
It's not visible. Please stop present and then again you can start
Okay, okay.
present.
I'll try again, sir.
Hmm.
Sir, how about now?
Yes, yes. Now it's okay.
So, afternoon all. My name is Anuvalil. I'm a PG student from St. Kitts College of Engineering. So, first of all, I just want to say thank you for giving me a chance to be in this part of conference. So, this work was co-authored by Engineer Manoj CM, Assistant Professor at St. Kitts College of Engineering. So, the title of this paper is Numerical Study on Thermal Performance of Fully Encased Composite Column. So, these are the contents. So composite column is a compression member comprising of a steel, concrete encased steel section or a concrete filled tubular section. We all know concrete is good in compression while steel is good in tension. These are widely used in multi-story buildings because of its enhanced performance in structure, in ambient as well as in fire situations. So the need of this study for the past recent years, the use of concrete encased steel columns has increased in the construction of high-rise buildings. So while designing fire resistance is an important factor, so here we have carried out a study to evaluate the thermal performance of fully encased composite column numerically using ISO 834 fire curve, and we have conducted a parameter study to understand the role of preloading, grade of concrete, shape of steel section, and cross section of column. So the work included the scope of the work where the work was carried out in Ansys workbench, and here the transit thermal analysis was carried out. Here ISO 834 fire curve was used as thermal. Then the material used was steel and of concrete of M30 grade. Here the steel sections were both steel sections were built up using Eurocode 4, and the parametric parameters were preloading of 500,000, 1,500, 2,000, and 2,500. The grade of concrete of M30, M40, and M50, where cross-section of column varied with 400 by 400, 450 by 450, 500 by 500, and 550 by 550. So the methodology of the work included started with literature study. Then we have designed the column using Eurocode 4, which was then modeled using ANSYS. And then analysis was carried out, and finally result and discussion and conclusions were done. So these are the column details of the first specimen with a column height of 3000 mm and a cross section of 400 by 400. Flange and roof section details and the reinforcement details are given. This is the model of the first column. So this is the details of the second column. And this is the model of the second column. So moving on to result and discussions. So maximum principal strain in concrete reached a value of 0.0035 when the maximum deformation in column was 4.33. for first column, and the equivalent elastic strain in steel was 0.0027. Then the parameter studies were carried out. Here the parameter of the loads of 500, 1000, 1500 and 2000, 2500 kN were done. So we can see from the graphics that by increasing the load, the deformation also increased. Similar is shown in case of maximum principal strain and also equivalent elastic strain in steel. Then next was the effect of grade of concrete. Here the grades of M30, M40 and M50 is shown. Here we can see that by increasing the grade of concrete, the deformation has reduced. Similarly, maximum principal strain and also equivalent elastic strain in steel. Then the effect of cross-section of column. By increasing the size of the column, the deformation also decreased. Maximum principal strain in concrete and equivalent elastic strain also similar. And this is the temperature distribution in concrete and steel for different cross-sections. And more details are given in the journal paper. So this is the result for second column for second model. Here the maximum principal strain in concrete reached to 0.0035 and the deformation was 7.46 mm. While leak in elastic strain in steel was found to be 0.0024. This is the parameter study. So here also similar results are showing and compared to that of the I section. By increasing the loading column, the deformation also increased. Similarly, maximum principal strain, equivalent elastic strain also showing increasing values. Then by increasing, next one was the grade of concrete. So by increasing the grade of concrete, the maximum principal strain, equivalent elastic strain, and also deformation in concrete decreased. And by increasing the cross section of column, you can see that the deformation in maximum principal strain and equivalent elastic strain in steel decreased. This is the temperature distribution in concrete and steel for different cross sections of second column. So from the conclusions, we can say that the shape of steel section, grade of concrete, preloading, and cross section of column has significant effect on thermal behavior of fully encased composite column. For given ISF air loading, fully engaged composite column with I and T section shows similar thermal properties in parameter study. Also, the grade of concrete has improved thermal performance of fully engaged composite column. For IM steel section, increasing grade of concrete from M30 to M50 decreased deformation of column by 60%, and in T section by 57.67%. While increasing engagement dimension has improved thermal performance of fully engaged composite column. For IM section, increasing cross section decreased minimum temperature in steel by 61.4% and maximum temperature by 58.66%. While in case of TMR section, minimum temperature in steel decreased by 62.89% and maximum temperature decreased by 56.68%. So some future scope is here where we can do the experiment study to evaluate the grade of concrete, shape of steel section and cross section of column. And also we can do experiment study to prevent the spalling of concrete at given temperatures and cracking pattern in column. So these are some of the references. And thank you.
Thank you, Anil, for your presentation. Anyone who wishes to ask anything, they may write in the chat box. Sudipta Ghosh has asked one query. You can read it from the chat box also. Is it
Hello.
possible to check the temperature difference between core and surface of the column in numerical and analytic study, which is practically possible?
Sir, we can check it the max. During the term in the evaluation, I think we can check it using software at different points.
Which software you have used while?
ANSYS Workbench.
In ANSYS software, is it possible to check the temperature difference between core and the surface of the column?
Sir, from my research, I have seen the data showing. Actually, it is showing the total. It is showing the results are total. So I'm not that much good in that software, but I can. But my work shows the minimum and maximum temperature to column.
Okay. So, thank you very much, Anil, for your presentation. And now I would like to invite paper ID 198, S. Naveen.
Sir, is this screen visible?
Screen is visible.
Oh, okay, sir. Shall I start my presentation, sir?
Please make it on a full screen mode.
Yes, sir, I will make. Okay, sir?
Yeah. It's okay. Continue.
Yes, sir. I am Naveen, a research scholar, and my supervisor is Dr. Govardhan Bhatt, sir, from Department of Civil Engineering, NIT Raipur. And I am presenting a review paper on the effect of supplementary cementitious materials on compressive strength of ECC. Coming to this presentation outline, mainly my paper is
We are not getting your sound. We are not getting your sound. Earlier it was there, but now sound is not there. I think there is some technical issues. I think sound is not there. You please check at your own end. Earlier the sound was there, but suddenly it stopped. Okay, you please leave the meeting and again join it. We shall wait. Let us wait for. Still now no sound. No sound from your side. At least okay, you please discontinue. You check at your own end, and we will continue. We have some time left. I would like to invite paper ID 129 to start his presentation. 129, paper ID 129.
Hello everyone.
Yes, please continue.
Can you see my presentation, please?
Yeah.
So, hello everyone. Thank you for accepting my article. So, my paper title is by the experimental analysis of ductile brittle change and the high density polyethylene behavior. The plan of this presentation is following by. We have introduction, experimental study, result and discussion, and conclusion. And on comparison to the manufacturing materials such as metal and glass and ceramic polymers and glass ceramic polymers are more used in different industrial area. Polymer is consisting a large molecule called monomers linked by covalent bonds. Polymers have three different classes according to their behavior. We have thermoplastic, thermostatic, and elastomer. In our study, In our study, we use one of the more thermoplastic polymers in industry. It's high density of polyethylene. High density of polyethylene is a semi-crystalline polymer. It's a plastic resin made by the copolymerization of ethylene and a small amount of another hydrocarbon. The HDPE is used in baking, for example, bottle, chemical container, and pipe system. So we have some physical and thermal properties of HDPE. We have volumic mass, glass transition temperature, and melting temperature. For state-of-art of use of HDPE, we have the case of Chevingli and Kang 2014. The main objective of this thesis is the comprehension, the mechanical and fractal property of HDE. Are comparing the experimental results combined with the numerical results. We use a crack of spacement of HDPE. The study of the mechanical behavior of high density of polyethylene for the development of this polymer is more important. So, in this article, we will study the mechanical behavior of high density of polyethylene under two notches defect. We have U notch and U notch. On this study is change of opening. The difference on this study is the change of opening length compared to notch depth. So, the condition used for the experimental study, we have the tensile test used MTS machine. For the tensile test, the material used is high density of polyethylene with a volumic mass of 995. The Young modulus is 1153 and the portion is 0.4. The opening have length of 5, 10, 60 and 80 millimeter with the same depth. We can see at the figure 1 the specimen used for the characterization of HDPE at the virgin state. The U-notch specimens at the figure 2, and the last figure is the HDPE specimen with V-notch. Now we will do some discussion of results obtained by the tensile test of this specimen. So we start the characterization curve. We can see, or we notice in the figure at the beginning of the test, the deformation is linear elastic up to 4 megapascal. This viscoelastic behavior allows the material to regain its initial shape of the load if the loading stopped. The last part at the 17 megapascal, it is the softening where we observe the decrease here, the decrease of stress by increasing of strain. This value up to break-in stress. So we will pass on V defects. We can see for 5 and 10 millimeter, we have the same value. Or the same evolve at the linear elastic zone. For 16 and 18, we have a critical result because the production of high glued for each increase in the opening length. For U-notch, we have two a linear elastic zone for 5 millimeter and 10 millimeter. We can see the linear part from the beginning to 7 megapascal. We can remark a heterogeneous zone here and here. Deformation of plastic. This is the plastic deformation, which can see in microscopic part the structure change by the spherolytic and at the fibrillar structure. The ultimate load increase with the increase with the rational length of opening weight. You can see that for the maximum stress. We do a small comparison about the V notch and U notch. We can see the value of stress of U notch is more important or is large than the V notch. So we can note that the U notch is more resistant than V notch because of the concentration of stress at the level of the V defect is more important. For the conclusion we have. The main objective of this work is to study the change of ductile brittle behavior of high density of polyethylene. The result obtained allows to decide that the length effect of the opening and type of defect are important factors to analyze the behavior of high density of polyethylene. The high density of polyethylene does not return the same property in the presence of defect, and this study is well carried out in order to avoid industrial breakdown such as the coupling shelves or pipes. Thank you.
So thank you. Anyone who wishes to ask anything, they may write in the chat box. Just one query from my side. You have done the experimental program in where?
Yes.
Where you have conducted your experiment program?
Yes. This is my experimental programs. We do four opening length, 5 millimeter, 10, 16, and 18 for U notch and V notch.
Okay. No, it's a program has been conducted in India or abroad.
Yes, I don't understand, sir.
You have done this research work in India, or you are
No,
abroad?
I am in Morocco, sir. I do this in the High Institute of Maritime in Morocco.
Okay. Thank you. So thank you very much.
Thank you, sir.
Okay, Naveen, are you there? Naveen?
Share my screen.
Yes. Now you are audible.
Sir, is this screen visible?
Yes. Screen is visible.
I'm Naveen, research scholar from my supervisor is Dr. Govardhan Bhatt, sir. I am presenting a review paper presentation on effect of supplementary cementitious materials on composition of ECC. Mainly the presentation outline consisting of what is ECC and what is the importance of the study which I have selected, then limitations of this particular study, then supplementary cementitious materials which I have covered for this particular review, and how these supplementary cementitious materials are linked with this composition of ECC. Then after, what are the advancements in composition of ECC at latest trend we have included. Then the recommendations from this review which I have suggested for the composition of ECC in view of this SCM. Finally, the conclusion. Coming to the engineered cementitious composite, this is primarily it is depending upon it will be designed based on the micromechanics and fracture mechanics principles, and it having higher tensile strength or ductility at low volume of PVA fiber, and because of its behavior, it can also be called as a bendable concrete. We can see that one from the picture. Coming to the properties, it will exhibit strain hardening behavior, and tensile strength ductility is higher, and the flexural strength also higher as compared with a regular concrete, is 2 to 3% higher. Whereas coming to this figure, we have taken this one from Victor Lee, and he is the further of strain capacity under the higher tensile strain, the tensile stress is higher for this particular ECC. That will be termed as a strain hardening behavior. Whereas we can see this fiber reinforced concrete, the behavior under the tensile loading is a strain softening behavior that may fail due to the tensile loading with a single crack. Whereas you can see the ECC, that final failure will occur after the several number of micro cracks, like multiple cracks. The cracks is less than 100 microns. That is the unique behavior of this ECC as compared with the regular one. Coming to the novelty of the study, basically the compression is also directly proportional relation with this flexural strength. so that we have selected the compressive strength of ECC with respect to the SEMs. Like for this particular study, we are considering the fly ash and GGBS and rice husk cache, and as well as this slag for this particular study or review. Coming to the limitations, actually the ECC cost is higher than compared with the regular or normal concrete because of the several reasons like usage of cement and fiber utilization, and as well as the manufactured sand utilization. In case of ECC, mainly it can be produced with the PVA fiber. The PVA fiber is cost also very higher as compared with the other fibers, and microsilica is also not available readily. It is a commercial product, so that it is these all the factors which increases the cost of the ECC, and we are suggesting that locally available SEMs can be used in ECC production. That will be more sustainable and as well as economic. Coming to the supplementary cementitious materials, why supplementary cementitious materials are using in particularly for this ECC means the cement content required for ECC is higher, like 600 to 1200 kg per meter cube, and the cement industry is also responsible for higher emission of CO2, that is of 8%. Particularly, we can see this different pictures of the supplementary cementitious material that we have selected for this particular review, and the color is also very different. That is depending upon the composition and silica content and unburnt carbon present in that particular thing. The color will be the different, and some silica fumes having gray color also. That is mainly dependent on the silica present in that particular compound. This is the microstructure of the ECC. Then you can see the spherical particle of fly ash. That is the reason why the workability is higher. These all the pictures we have collected from the other studies, that is a 15 micron. I mean, we can't able to see the silica film because that particle of silica fume is less than the cement and as well as the fly ash one. Due to when we are selecting the silica fume, the usage of high range water reducer also is suggested for the better strength and workability point of view. Coming to this effect of SEM and water to binder ratio on compressions of ECC, and this picture, this graph represents that with increasing of fly ash content and replacing the cement with the fly ash, like 50% up to the 80%, they have replaced. With the increasing of replacement, automatically the strength was reduced because of several reasons like lower water to binder ratio and increased amount of fly ash that may not react properly. That is the reason why the reduction of compression will occur in case of ECC. And we can see this one here picture that represents how the slag will affect the compression of ECC. With increasing of slag content as a replacement of cement, the strength of the ECC is reducing at constant water binder ratio. And we can also see this one, the ternary blends like fly ash, rice husk ash, silica fume. The combination will improve the strength of the ECC at a constant water to binder ratio. Especially while selecting the rice husk ash and silica fume, the silica content is a main responsible for the strength and reduction of the voids or pores formed in the ECC. That's why due to the structure, I mean a denser structure that make higher compressive strength. Coming to this one, here we can see how the fly ash will affect the compression of the ECC. With increased fly ash content, automatically the strength will be reduced drastically. And here we can see that with the combination of fly ash and silica fume, automatically the compression of ECC is increased with the inclusion of silica fume in this ECC. And these pictures represent that the compression strength with combination of fly ash and slag also improves the compression of ECC. Then slag particle is angular, then the fly ash particle is in a spherical in shape, and these will fill the voids that will present in the composite. Automatically that makes the structure denser and microstructure is strong. That is responsible for higher compressive strength. And this picture represents that at constant replacement, like it is a fly ash or rice husk ash or a silica fume, with increasing of water to binder ratio, automatically the strength is reduced. At here, the lower water to binder ratio, the strength will be higher. With increasing of water to binder ratio, the strength will be lower. Means what binder here, the binder indicates that fly ash and cement. the combination of two, we can call it as a, summation of these two, we can call it as a binder. That may be the other SEMs like silica fume or rice cash or GGBS, we can call it as a simply a binder. So higher binder water to binder ratio is responsible for lower compressive strength of ECC. And while preparing the ECC, the compressive strength is also influenced with the water to binder ratio and the type of SEM which we are preferring. Coming to this improvements, recently that ECC having higher compression has been developed by Ranade or Beyond Bioto at 2021, that is a higher than 200, like a 210 MPa. Then recommendations from selection of SEM. Basically, while selecting an SEM, the composition of this particular SEM should be static. We should have to take care while selecting that particular SEM, like what are the composition or what is the chemical characteristics it's having. Suppose we can take a rice cash, the rice cash we can having a different properties. If you having prefer the field burning, or it is some the I mean the present of silica or the present of carbon content, it depending upon the burning condition also, how we are burning. And one more thing is, for achieving the normal strength like 30 to 80 MPa ECC, we can prefer the fly ash and slag. It is the best option for improving of strength up to 80%. If you wanted to design a ultra high performance ECC, like strength is greater than 200, then we can adopt 2 or 3 combinations of this SEMs for higher strength of ECC. Then coming to the conclusions, here mainly we are suggesting that whenever to select a SEM that should be utilized in ECC should consisting of proper the chemical composition. Then we should have to take care about the chemical composition before selecting that SEM, like different SEM, not only this rice husk cash, fly ash and GGBS, some other sugarcane bagages will be also used recently, that can be used as a stand replacement in case of production of ECC. Then coming to the water to binder ratio. Water to binder ratio is also one of the important factor that will decide the compressive strength of ECC in addition with the SEM. Suppose if you are encouraging the use of these SEMs in production of ECC, automatically it reduces the cost of ECC in one aspect, and one more aspect is it can also reduce the carbon or energy footprints, and it will lead to the development of sustainability. Then coming to this one, most of the studies we observed from the literature, most of the studies including the fly ash, based on the fly ash content also, the ECC is classified as a M45 ECC, because that is a code that was given by the Victor Lee and other authors based on the fly ash to cement ratio. If the fly ash to cement ratio is a 1.2, then that will be called as a M45 ECC. If the fly ash to cement ratio is higher, then we can call it as a high volume fly ash ECC. Then most of the studies are showing that they are using fly ash and GGBS, some other SEM, and we are also trying to encourage this locally available SEMs also be used for this ECC strength development. This is the these are the references we have for this particular paper and a review paper. Thank you.
Thank you, Mr. S. Naveen, for your research work, and I think this work is more of a review type. So, am I audible?
Yes, audible.
Yeah, okay. So, you are currently doing what is your research topic in there in NIT Raipur? Are you doing some research or experimental work, or you are doing both experimental as plus numerical modeling?
I am initially planning experimental one. Then also I am planning for some numerical modeling related to the earthquake point of view, sir.
Okay. So, have you actually selected the that SCMs, or which type of partially replacement of cement or for aggregate sand? What future you have, or what topic you have actually selected?
I have selected only based on the supplementary cementitious materials only, sir, and
Okay, okay.
cementitious composite. Then, in addition to that, we are replacing the sand, regular
Okay.
silica. Actually, the ECC is producing with the microsilica sand. That is
Yeah,
a
yeah.
product. So,
Yeah.
makes more expensive to produce a ECC. So that we are completely replacing that silica sand with this our regular river sand, which is
Okay,
available
okay.
with a different
Okay.
how the behavior in compression, in tension, and durability point. Then after, we are also replacing that regular sand with the steel slag which is available locally in our region, Raipur region. We can plant. We can get that steel slag free of cost. Then we are also including that one, how the properties of the ECC is changing with the different gratings.
Okay, okay. So thank you very much for your valuable queries and valuable suggestions. So this is all about this technical session today. I'm very thankful that you all have given your wonderful research experience and your precious time to our organization, that is JP University of Information Technology, and I congratulate you all that you have given your presentation also. So this is all about today, and we will again meet tomorrow for a new technical session and with new research papers. Okay, so thank you very much again for all the authors. And someone is absent, I think. Dheeraj Kumar Singh, are you present? Naveen, you please stop your present. Dheeraj Kumar is present or is absent. So okay, so we may stop here right now, and then we will meet again tomorrow. Thank you very much.